Performance indicators. Precision, a measure of reproducibility of a particular set of analytical measurements on the same sample of test analyte. If the replicated values agree closely, the measurements are said to be of high precision. In analytical biochemical work, the normal aim is to develop a method that has a high precision as possible within the general objectives of the investigation. However, precision commonly varies over the analytical range and over periods of time. As a consequence, precision may be expressed as either within batch or between batch. Within batch, precision is the variability when the sample test is analyzed within the same batch of analysis on the same day. Between batch, precision is the variability when the same test sample is analyzed repeatedly during different batches of analysis over a period of time. Since there is more opportunity for the analytical conditions to change for the assessment of between-batch precision, it is higher of the two types of assessment. Results that are of high precision may nevertheless be of a poor estimate of true value, i.e. of low accuracy or high bias, because of the presence of unidentified errors. Accuracy, also called trueness, bias, and inaccuracy. This is the difference between the mean of a set of analytical measurements on the sample test of analyte and the true value for the test sample. As previously pointed out, the true value is normally unknown except in the case of standard measurements. In other cases, accuracy has to be assessed indirectly by use of an internationally agreed reference method and/or by the use of external quality assessment schemes and/or by the use of population statistics. Detection limit, also called sensitivity. This is the smallest concentration of the test analyte that can be distinguished from zero with a defined degree of confidence. Concentrations below this limit should simply be reported as less than detection limit. All methods have their individual detection limits for a given analyte, and this may be one of the factors that influence the choice of a specific analytical method for a given study. Analytical range. This is the range of concentrations of the test analyte that can be measured reproducibly, the lower end of the range being the detection limit. In most cases, the analytical range is defined by an appropriate calibration curve. Analytical specificity, also called selectivity. This is a measure of the extent to which other substances that may be present in the sample of test analyte interfere with the analysis and therefore lead to a falsely high or low value. Analytical sensitivity. This is a measure of the change in response of the method to a defined change in the quantity of analyte present. In many cases, analytical sensitivity is expressed as the slope of a linear calibration curve. Robustness. This is a measure of the ability of the method to give a consistent result in spite of small changes in experimental parameters such as pH, temperature, and amount of reagents added. For routine analysis, the robustness of a method is an important practical decision.